You may be familiar with the right triangle definition of the sine, cosine, and tangent functions, where if theta is some angle in a right triangle, and theta is not the 90-degree angle in that right triangle, then we have that sine of theta is equal to the length of the side opposite to theta over the length of the hypotenuse of that right triangle that theta lives in. And similarly, cosine of theta is equal to the length of the side that's adjacent to theta over the length of the hypotenuse of that triangle that theta lives in. And lastly, tangent of theta is equal to the length of the side opposite to theta over the length of the adjacent side to theta, the length of the side that's adjacent to theta. And then we can also define the cosecant and secant and cotangent functions, where the cosecant function is just the reciprocal of the sine function. So it's just hypotenuse over the opposite. And then cosecant is, or rather secant is just the hypotenuse over adjacent. It's the reciprocal of the cosine function. And cotangent is just the reciprocal of the tangent function. However, there's one sort of small issue with this definition. This definition only works if theta is small enough. If the angle theta exceeds 90 degrees, then this definition doesn't apply. Well, why won't this definition work if theta exceeds 90 degrees? Well, if theta exceeds 90 degrees, then there doesn't exist any right triangle with an angle theta that's greater than 90 degrees. Think about it. Any right triangle, the largest angle in a right triangle is 90 degrees. So if theta is greater than 90 degrees, then there doesn't exist any right triangle that has theta as one of its angles. So how do we fix this? How do we take the sine of an arbitrary angle, and in particular an angle that's greater than 90 degrees? Or what about if we want to take the sine or cosine or tangent of a negative angle, a negative input to this sine function or cosine or tangent function? Well, check out part 2, where I talk about the unit circle definitions of the trigonometric functions, where this definition, this right triangle definition, is extended so that we can take the sine, cosine, and tangent of any angle that we could possibly want, an arbitrary value, an arbitrary input to the sine, cosine, and tangent functions.